Hello and welcome to the Azure User Group Cloud Secrets to Go pre-show. So this is your 2-minute warm-up for the Azure Group meeting happening today. So with me today, I have a very special guest, and I have definitely been watching way too much TikTok. Not true. It's Glen.
No, it doesn't work.
So Glen, can you also do like this? There we go. Almost. Morten is with us today. So,
Yes.
Glen, you're double hosted. Isn't that awesome?
Yeah, that's more than I expected. So happy to be here.
Awesome. So, for people who's new to the user group, Morten and myself are a part of the organizers. And Glen is our superstar visiting today, all the way from Belgium. In Belgium. So
it was a long trip.
I can imagine. Yeah, no, we'll definitely take you out for beers later somehow. Okay, so we are at the top of the hour now. Just bear with us for a minute or two, like while people are joining in, and we will get started. I think about 2 minutes past. We will give the stage to Glen here. So, how's Belgium? How's the weather?
Well, it has been quite a good weather, sunny, actually, surprisingly. Yeah, it's Corona is not treating us well, but the weather is a-okay at the moment, and has been for quite some time. So I'm not complaining. So.
Cool, great. So Morten, we already have a question inbound here, and this is actually for you. So are you sharing the stuff that you are growing in the background?
Yeah, definitely.
So what are you growing, man?
It's chilies.
Okay, sure. I believe you. Okay, cool. So yeah, actually that question was for me, but hey.
You were hoping. I know it. I can see it.
Yeah. I wonder why we never meet at your place. Cool, great. So as we get started, let me just set the scene here for the Azure User Group. So we are 2,000 plus people who share a common passion for cloud computing and the topic of Azure. So we band together on meetup.com. So I hope most of you joined via that channel. And just go there, sign up for our meetup page, and you will get notified when we post new events. What we have planned for you coming up here, let me just find that slide for you, is next week. We have on the September 9th, we have 9 cool AKS features with Gustav from Microsoft. He's a Microsoft Black Belt focusing on open source technology, and open source technology in Microsoft lingo is AKS. So we'll do a technical, perhaps not deep dive, but we will definitely look at what's new and what we have here just ahead of Ignite for AKS. So I encourage you all to check out that session. It's posted on meetup.com. Sign up and you will get the link for the broadcast. So back to today's event. Glen is here. Glen, let me just put on your presentation. So thank you so much for joining us today. We're so honored to have you here. And Glen, I understand you have totally fresh content for us.
Yeah. So let me just mute myself a bit. So I will be talking about a brand new service that is called Azure Digital Twins. Actually, it has been around for 1 year and a half, but it just got a refresh, a very new deployment. I believe, somewhere end of June. So I will be walking you through the new features, what it can do, and yeah, actually, this session will not have too many slides. It will most of have some hands-on material and some demos to actually get an idea on how the service is working, and hopefully at the end pop some ideas or some questions into your head, and I will be happy to answer them. So
Excellent.
if okay, I will let's start with the session.
Yeah, sure. Let me just introduce you, because I know who you are and how awesome you are, but the audience might not be. So absolutely, questions in the chat, please keep them coming. We will moderate them at the end, and Glen will be happy to answer, I'm sure. But
Yeah.
who is Glen, right? So Glen is the founder of Azure Belgium, so the Belgium division of this really great company that's been led by a bunch of awesome Microsoft Azure MVPs. So Glen is a 6-time Microsoft MVP, if I'm not wrong.
Yes.
I can still count, but also a crew member of Azure User Group Belgium. So also a host of these types of event. Glen has been in the business for a while, focusing not just on Azure, but also IoT solutions. And believe it or not, I'm just going to spill the beans here. Glen used to be a Silverlight developer. How awesome is that?
Oh.
I don't think you need further introduction. Otherwise, I would just hand it over to you here to take it from Silverlight and leave the stage to you. So thank you for joining us. The stage is yours, Glen.
Thank you so much for the nice introduction. So let's continue. So as already mentioned, I'm Glen. Feel free to reach out to me through any of these channels. Don't hesitate to drop me an email or to mention something on Twitter, and I will be happy to help you. So I've been working with Azure quite some time. I also did some Silverlight in between. But let's just continue with that. So I'm working for Azure. I basically founded Azure in Belgium, but Azure has been around since 2011. We mostly focus on Azure. We have offices in Helsinki and in Belgium. And we have a couple of cool Microsoft logos for you. So that's always fun. But that's not what we are here for today. So today we will talk about IoT. So, and for people that are not familiar with IoT, the most simple idea of IoT is about devices, getting those things connected, and creating some insights and actions on those data and those measurements you're seeing. So, and when you start an IoT project, the most difficult question or the most important question you need to ask if you either go for platform as a service solutions or if you go for a software as a services approach. Azure and Microsoft itself offers solutions for both of these areas. So depending on how, on what your business case is, what your need is of your project, you could either go for PaaS or implement a software as a service solution. Remember, the biggest advantage of choosing for platform as a service also comes with one of the biggest challenges, is the fact that you are in full control of everything, and you also need to have take into account that you need to manage some cases like scalability and so on. So as already mentioned, before we go into details about the subject of today, I want to give you a brief introduction on the Microsoft product portfolio and to take a look on where Microsoft is currently investing its time in. So first of all, you have your Azure IoT Solutions. And this is, you can see those as your platform, as your software as a services solutions. So there's IoT Central, which allows you to basically create IoT solutions with a matter of a couple of clicks. You can immediately start doing that. Of course, you have to live with some of the limitations that you give away if you would implement everything with platform as a service. Then you have your IoT accelerators that are just, let us say, sort of reference implementations of IoT solutions. And then there's the Azure IoT Services itself. This is the platform as a service area where you have, of course, IoT Hub, Digital Twins, time series insights, the device provisioning service, and so on. During this session, we will definitely come in contact with Azure IoT Hub and time series insight, and of course the Digital Twins. But I will go into details on that later. And then, of course, a big investment and a big area where there has been a lot of improvements the last couple of years is the edge support, where you basically start offloading your intelligence that is running in the cloud or your compute that is running in the cloud. You would offload that to your devices, or as close as possible to devices, to really have that faster feedback loop close to your device instead of having to do calculations in the cloud. And then there's a whole portfolio that is more focusing on the device side itself. I'm not going to go in much details about that, but there's Azure Sphere that is that are highly secure microcontroller units. There's the Windows IoT platform, and of course there's the Databox Edge, Azure Stack Edge, and so on. So with that said, today we are moving more and more to like a new generation of IoT solutions. While IoT solutions usually focused on just having your assets connected, transmitting their data, and just doing some basic analytics on top of them, we see more and more that customers want to model a physical environment first, and then keep that physical model up to date with IoT data. They really want to have, they want to model relationships between those environments, those data about those environments, and having, really creating that that connected ecosystem where you have close interaction between your environment, your people, and your devices, so that you can really create a nice state of use for your people. So before we jump into details about digital twins, I want to mention that the service went in preview end of June. So, and this is actually the version 2 of the Azure Digital Twins. So there was an initial version of it, which has been completely revamped to host that V2. So everything I'm going to say during this session, remember this is still a preview service. Remember that things might change before this service goes GA. So maybe the next thing I want to briefly mention is the difference between version 1 and version 2 are quite significant. So they are based on the feedback of customers that have been provided by the team. So first of all, modeling your environment is now more based on standards. There is a more flexible topology definition, so it's more easy to really create a topology inside your digital twin environment. Version 1 was based on you could hook up external compute or external functions, but those functions were only in JavaScript, while the new service is really focusing on bringing that additional value of the Azure platform, bringing that to Azure Digital Twin, and basically it has moved the entire compute outside of the Azure Digital Twins, but more on that later. So in the older V1, also IoT Hub was baked into the product, while now you can basically bring your own IoT Hub and transmit the data towards digital twins. Also, there has been a lot of improvements done on scaling and so on. So let's jump into the details. So Azure Digital Twins, as already said, it is a solution that is there or has been created to allow IoT developers or customers that wants to build an IoT solution to really have that next generation approach on building IoT solutions. So really starting from the people, from the use cases, and not from the device. So the focus here is the environment, the people, the use cases, and you feed that model or that use case with the IoT data. So a couple of important points that the new Azure Digital Twins have, and I will be jumping into details on each of those. So it has a new open modeling language. It has the live execution environment, allows you to keep your model up to date with IoT data. And then, as already said, you can feed data from IoT devices with IoT Hub, but it's perfectly possible to update your execution environment and your model with other business data, as the service has a very rich API to interact with. You can output the data that is flowing through the system. You can output that to time series insights. You can add additional storage and analytics on top of that to really create that big IoT solution. So let's first of all talk a bit on the open modeling language. So the open modeling language basically allows you to create custom domain models using the digital twin definition language. So it's DTDL. So that definition language that used to be limited to digital twins itself, is now based on adjacent standards, and it's also used across the IoT services in Azure. For example, it is using the same standard as IoT plug and play, and it also allows you, it uses the same model as time series insights, for example. So that modeling language has been a standard now. So once you can start describing your digital twin through properties. And properties are just properties as you know them. It is a simple data field that has a certain state or certain value. And important to mention is that properties are backed up by storage. So that means they can be read at any time. So they are a certain state of your twin. The next thing is telemetry. So telemetry is basically telemetry as you know it. It's measurements of events, sensor readings, and so on. There is an important difference between properties and telemetry. While properties are stored on the twin, telemetry fields, they are not. It's a series of data, basically a sort of streams. Next, of course, you have components. That allows you to define model interfaces if you want to have more complex. If you have more complex twins, for example, if you want to model a cell phone, for example, you can have a component being a camera, and you can use that component as the front and the back camera. So that allows you to you can see it as a sort of module. And then maybe the most important one is relationships. And relationships, it's a difficult wording, so let's try that again. Relationships, it's a way of allowing you to define how your twin is interacting with another twin and what is the exact relationship between the different twins. But I will definitely dive into details on that one. So, so the models that you will create, the twins that you are creating are define those semantic relationships, and they allow you to create a graph of that twin. They allow you to create a visual graph of that twin. So as already mentioned, digital twin definition language is aligned with IoT plug and play and with the time series data model. So let's immediately jump to Visual Studio. If all goes well, you should see my screen. So what I did for this demo, let me zoom in a bit, is I've modeled my my house where I live inside digital twins to have like a more visual a visual idea on what how a model could look like. So important here is if I zoom in a bit more. So this is how a model looks like in digital twin. It has a couple of fixed data fields that you need to fill in. So for example, the type here, the type must always be interface. So if you're working with digital twins, that will be your type. So then the ID, and that's a rather important one. That's the ID of your model. In our case, you have to use DTMI, then your domain. In our case, this is just the demo domain. Then an identifier of your model. In my case, this is my top level, so it's my house, and you have to end with a version. So this is version 1 of my digital house. So then you can give it a proper display name, and here the context. The context is just a fixed value that is also required for you to use within Digital Twins. So, and all remaining interface data of all remaining data that you need to define is here provided within the contents. That's an array of different elements. So as you can see here, I defined 2 properties. If you remember, these properties are just state. And yeah, you define the type, you give it a name, and what schema that it uses. In our case, this is just a simple string of construction year. I should have maybe defined an integer over there, and the owner here. The quite interesting part is here where we define our type as a relationship. So the target that we have here is type relationship. We can give that relationship a name. So in our case, that will, our house has a couple of floors, and we target a certain ID. So if we would take a look at that target, so if we would look at the model of our floor, you would see that that ID is matching the relationship we had in our house. Again, we're now on the level of defining our different floors. So we have our ID, type again interface. Our display name is just a display name. This is the fixed value of Digital Twins, and my my floor or my model floor can have a relationship with rooms. So we gave that a proper name, and we have a target ID of rooms. So if we take that a level further, you can see that this room, again, type interface, proper display name, this is fixed, has, again, a couple of properties. And those properties, I gave them temperature and humidity. And also, I have a relationship to my sensors. So if I go to here, I should rename that JSON to sensors. So as you can see here, I have my sensors that are defined in each room. Each sensor has a firmware version and has a temperature and humidity sensors. So this is how you should model, or how you can model your environment in Digital Twins. So I have to be honest, this was a bit of searching your way around how to properly use the different types and so on, and how to properly define the relationships, because I will talk to that during the next part, when I talk about the live execution environment. When you upload this model inside your execution environment, this target ID will be validated. So it's important that you get that relationship correct once you start building that twin. So let's briefly jump back to the deck. So now that we've modeled our twin, we can start talking about the live execution environment. So twins are connected into a graph by defining their relationship. So the relationship that a twin can have is defined, as already said, as part of the model. So for example, in our case, we have a floor that contains different rooms. That room contains sensors. You can visualize those model and those twin instances. Maybe I should mention that first is if you upload a model to your execution environment, you can start defining digital twin instances based on those models. And those instances basically form then the relationships of those things. There is a very cool tool that allows you to visualize how your twin is looking like. That is called the Azure Digital Twin Explorer, but I will definitely come back to that in detail, and I will show you that one. So you can use, there's a rich eventing system that will that allows you to move data around the twin, to call external compute such as Azure Functions and so on. You can extract data from the live execution environment through the Query API. As you can see, the Digital Twin Explorer will use that Query API to get that data. That Query API also allows you to query the quite complex conditions and so on. And important to mention is that all the inputs of the data can come through IoT Hub, but can also come from other data sources. And there it's just as simple as calling the API. So there has been an SDK developed by the team, which of course uses the API in the background, and we will walk you through that one. So that's it for the slides. Let's jump back to the Azure portal. First of all, let me click this one here. So let's first of all go to Azure Digital Twins. So if you spin up or if you create a Azure Digital Twins, this is what you will get. You will get a nice getting started. But one of the most important things is that you need to create is an Azure Active Directory application that has the, let me show you that one. If we go to role assignments, let's see if that comes up. So you need to create an Active Directory application that has the Azure Digital Twin scope, and the Azure Digital Twin owner. That is really important to have, that you correctly set that up, as a lot of the things in the preview are heavily depending on this role. So it's not enough that you have owner of the resource, it's really important that you set up this role correctly across your entire solution so that your digital twin can access that. So once you have that instance up and running, you can start creating your digital twin. So first of all, let me kill that one first. Sorry. So what I will do is I will start the Digital Twin Explorer tool for you, and I will show you what I've already prepared. So while what I've prepared is I've already pre-uploaded all the models that I've defined towards that digital twin. So if all goes well, and if this Digital Twin Explorer comes up one day or another, we would be able to see the different models that have been deployed inside the digital twins. So, and let me already open this one first. Let me see if it's already there or not. So it's still waiting for localhost. So what I will do is walk you through how you can create a digital twin through by using the SDK. Let me see if that's just hit refresh and wait for that one to come up. So what we already did is we uploaded the models to the environment, and then what we will do is we will start creating our digital twins. So this is the piece of code where you start defining your metadata. For example, what model I want to use. So I will first of all define my house. So remember what I said, it's important to have these values correct. And next to the metadata, you also have to provide the other twin data. If we would go back to the model, you would see that the contents of this model have a construction year, an owner, and a relationship. So if we go back to digital twin, you see the construction year, the owner, and then the metadata that's just digital twin specific that needs to be there. So we have a client that is just the digital twin client from Microsoft, from the SDK. So this is the NuGet package that is used is Azure.digitaltwin.core, and we are just using the digital twin client to interact with. So what we do is we say, let's create a digital twin async, and we give that digital twin an ID that we can choose ourselves. And then we need to provide a string, a JSON string with the twin data we've created here. So, and this is if you would call the Azure Digital Twin instance with that, you will get your twin created. The same for the floor. So again, we define the metadata. So the model is our floor, kind is just digital twin. Remember, our floor only had a relationship, so we don't need to define any further properties. So what we can do here is with 3 different commands, we create 3 digital twins with the same model, but with a different ID. So there will be 3 twins instantiated based on the same model, but they will have a different ID representing each floor of the house. So the same for the rooms actually, and then the interesting part starts. So we have defined our room. We created our sensors, and then we can start defining the relationships between them. And this is where the power comes into play. So you have to specify the target ID and the relationships that you're using. Remember, a house had a relationship named floors, and so we're targeting floor 1 here. So if you would take a look at that, our ID of our house, so Digital Twin ID, local host with relationship ID, and we provide this body. So with this piece of code, our digital twin with this ID will be mapped to floor 1. The same with floor 2 and floor 3, and then we each time take it a level deeper to really start building that house. Let me just show you another one. So this is, for example, a floor to a certain room. We have a target ID kitchen, and we create a relationship between floor and this metadata being the kitchen with the relationship name rooms. And we have to specify the ID. And this is basically the way how you build up the entire digital twin by defining this piece of code. If you're interested, this code is available on my GitHub, so don't hesitate to take a look at that one. There's also a perfect end-to-end sample available on the Azure documentation, so I would suggest to also take a look at that one. So if all goes well, yes. This is the code I was talking about, the Digital Twin Explorer. So as you can see here, I am now connected to Azure itself. Let me zoom in a bit here, if that works or not. So this interface is connected to my Azure Digital Twin instance. As you can see here, it has my my different models available, but this is just the models itself, and there is no digital twin available. So if we go back to the demo, remember we have a whole set of codes to create that one. Let me start that one up, and let us run the code to create the twin. So it's taking some time. I think my laptop doesn't like the streaming that much. So yes. So what we will do here is just set up digital twin. Let's hit enter. And now it will run through the pieces of code I just explained, creating the instances of all the twins. If all goes well, Of course. As you can see here, I will need to authenticate myself first. It should, let me take that one, if all goes well. So authentication is complete. First of all, he will delete everything. And then he will start creating the different twins. As you can see here, the local host twin being created, the different floors, creating the rooms, then the sensors, then all the relationships between the room, the sensors, the house, and so on. If we would return to our Digital Twin Explorer, if all goes well, you would see a graphical formation of how our twin was created. You can use different layouts on top of that. So this is really a nice tool to show you how that looks like. So as you can see here, these fields are all just digital twins interconnected with each other through relationships. So the question is, how do you keep this environment up to date? As already mentioned, it is using it's leveraging the full eventing and messaging of Azure in combination with compute. So therefore, we need to jump back to the Azure Portal, where we have a IoT hub. Where we have IoT hub and we have some IoT devices defined. So for this demo, what I did for each of the different sensors I have available in my demo, I have created a specific device ID. Later during this session, I will start ingest data for each of those device IDs, and that way you will see that the environment will keep itself up to date. So how do these events, those telemetry, basically end up into Azure Digital Twins? How it happens, it is using event grid events. Excuse me. And it is, there is an event subscription that is using device telemetry. And basically, each time there's a telemetry message coming in, we process that data through an Azure function. And that Azure function, what that Azure function simply does is it takes in the data. So this is the process hub code. It takes in the data, and then what it will do is, again, by using the telemetry client, it will just update the digital twin and then do an operation, an add or replace with the property path and the value. So again, here it's leveraging the APIs that are available of digital twins, allowing you to call each separate twin and updating its value. Let's quickly jump back to the slides. So storage and analytics. You can extract data from digital twins by routing messages through Event Hub, through Event Grid, or to Service Bus. And as already mentioned, routes and endpoints allow you to build a different scenario. You can store data in data lake, you connect to logic apps, you can connect to time series insights, and so on. It's really depending on your use case that you can use that to the maximum. So in our case, but I will go into details on that one, we will integrate with time series insights. So, and how do you do that? In Digital Twins, you can create an event route that will trigger certain events when a twin changes. So for example, if you have an external component that is updating the temperature of a certain digital twin, there will be a event being published. So we capture that event, we do some patching on top of that, and then you can forward that to your time series insight instance. Let me just jump back quickly through the Azure portal. If we go to Digital Twins, and if you're familiar with, let us say, IoT Hub, IoT Hub has a similar approach, but here you can you can connect your outputs via connect outputs. In our case, we have two different endpoints here. One is Event Grid, one is Event Hub. If we so you can create as many as you want. Basically, you gave it a name, you select the type, and then you need to give your exact connections to that service. Let me not save that. Yes, and then the power actually is in the event routes where you select a certain endpoint and then can start filtering on specific events that are being raised by your digital twins. So so that allows you to really build those end-to-end scenarios. So let me quickly jump back to the slides. So I'm going to show you the end-to-end demo that was prepared. So there, as already mentioned, I will have simulated devices that will transmit the data to IoT Hub. IoT Hub will raise an event, and Azure Function will handle that event and update the linked digital twin instances with all the values. The digital twin, as shown, we have uploaded the model towards that one, and we created all the necessary twins. So once we start feeding Azure Digital Twins with different data, Azure Digital Twins itself, based on the routes and the endpoint, will start transmitting, will start raising events, and those events will be picked up by event hubs, and then we have event hubs linked towards time series insights, allowing us to have a visual details of the telemetry that is flowing through our twin. So let's jump to the demo. So remember, we have our model, we have our twin defined. If we look here at our different sensors, you see that temperature and humidity is still put at 0. Let me close this one. And let's fire up the device simulator. So it's just a basic device simulator that will, I think, each couple of seconds transmit a message to IoT Hub for each device. It will transmit humidity and temperature, and allowing you to allowing you to simulate a sort-like environment. So let's see how that one is firing up. As you can see, the events are being transmitted. I have here a other tool from Microsoft that allows you through a console application, allows you to connect to a running digital twin instance through the console. So let's give it some time to spin up. And then what we can do with that console application is we can start monitoring our twin in a live way. It's authenticating, so it's taking some time. I'm signing into my account. Yes, that's me. Authentication complete. If all was well, I should. So what I can do here is use a command that is called observe properties for tstat001. Let me just check if that is one correct. So we will start monitoring this digital twin, and we will monitor the temp. But as you can see here, we're now live querying that digital twin through that console application. But as some of you already saw in our Digital Twin Explorer, we also already see the values being propagated to our twin. So you see that our twin is being updated by the IoT data that we're transmitting. So in this demo, I'm only pushing updates towards that specific sensors. But what you can also do is create a more complex scenario where these readings really propagate through through your entire twin. So as mentioned, we also have time series insights connected towards our environment, towards our digital twin, or our twin is exporting its data towards time series insights. So let's quickly take a look at that to wrap up this demo. So for people who are not familiar with time series insights, you could it's a visualization of your real-time IoT data. So if I put add here, let me maybe zoom in a bit more. And so let's put them shared and maybe put some bigger interval here. So as you can see here, this is not saying that much, but it shows you how you can propagate or extract the data from your digital twin and really use the entire Azure platform around that to build those end-to-end scenarios. I see that we're close with time, so let's quickly jump to the conclusion and then jump to Q&A. So this is the reference architecture. As you can see, I've took some bits and bytes of it to show you some parts of it. All this data is available on Microsoft documentation, on the Azure documentation. So if you're interested, be sure to take a look at that one. A quick conclusion is, as already said, it's Digital Twin is a service in preview. It is built around the ability for you to model your environment, and it's really focusing on building experiences for people, and no longer having your classic IoT solutions where you focus a lot on the devices, but here we're focusing on the experiment that people have, and really have your IoT environment defined instead of your devices. So, as already said, it has an event-driven approach, and it's controlled using REST APIs. It's using the SDK, and it has a platform as a service approach, and leveraging basically all the IoT components or the IoT offerings and services that the Azure platform has, leveraging each of those strengths to bring you a very cool service to build those IoT solutions. So with that said, let's jump to questions. I'm happy to answer them. I know we run out of time. Sorry for that. But I'm happy to stay a bit over time to answer questions. If not, if you have questions afterwards, drop me an email, do a shout out on Twitter, and as already mentioned, the demo code will be available on GitHub. And yeah, I will be glad to accept some pull requests. So yeah, with that said, I'll leave it to Morten to see if there are some questions. I'm not seeing them on my side, unfortunately.
No. So, well, first of all, thank you so much for the presentation. Really appreciate you taking the time to share with us today. I certainly learned a lot of new things. IoT is not really something I work with on a daily basis. More of like an interest, I guess, because I work in another space. So it's quite interesting to see all of this. So a lot of new stuff. But so we do have one question here, which I brought up. June asking, is it on the roadmap to provide native integration between IoT Hub, Digital Twins, GSI? Plumbing IoT solutions with Azure functions everywhere does not give me much confidence.
Yeah, that's a very good question and a very perfect remark. So everything is now really focused on like Tone mentioned, on plumbing that data through functions and then updating everything. It would be really nice that you have a let us say a built-in route to Azure Digital Twins through IoT Hub. I am not aware of that, but I can assume that is a feedback that Microsoft will receive a lot, because it is just writing plumbing code. It's writing the same code over and over again. So I would assume that that would be an option for them, but I'm not sure. I should check that with the team itself. I would say, bring that feedback to the team through the different channels, and they will definitely take that up with.
All right, thank you. So I don't see other questions popping in, but so I do have one thing which I wondered about in this. So I'm curious if this digital twin, if it's a missing piece, or if you think it's a missing piece in the IoT landscape, or if it's just something new, is in a new capability that you get for certain scenarios. Or
it was a missing feature that was there, especially, let us say, in the smart building area. There I can see a perfect fit. They expanded that to really make it a smart everything, so you can basically model everything. But this service really came from the smart building, the smart office environment, and I really can see some added values in those type of scenarios where you have your graph that is where your graph acts as a core component of your IoT solutions, or as your experience to people.
Yeah. Okay. And so in terms of scenarios, because this can be somewhat abstract to reason about, maybe if you're not seen it before, but is it, so you mentioned smart buildings, but is there any other scenarios that this would be a good fit for?
I can see it being used on industries like factory floors. I think Microsoft put out some pretty cool reference cases where digital twin is being used in different areas. I think they're available on the Azure documentation, so I can see a fit in a couple of scenarios. But for me, it feels more what I would use it or consider it is within a smart building, smart context space first. But of course, depending on the use case, you could bring in other use cases, of course.
Yeah. All right. Cool. Thank you. Yeah. Right. So I think that's it. So it's just we have one comment more than a question from June. But yeah, so I think that's it for now. So I'll just bring up that slide again, so people can take down your information, and be sure to follow Glen on Twitter. I guess for updates on IoT, is that some of the stuff you tweet about?
Yeah, and random ranting about other stuff. So
perfect.
I'm also very good. I tend to find some of the coolest GIFs as replies, so I try to be original on that one. So if you want to stay up to date on Azure and IoT, I want to have a good laugh once in a while, you can follow me on Twitter.
Then follow Glen on Twitter. Yeah. Perfect. Perfect. Thank you so much, Glen.
Before we end, I also want to thank you for having me. Unfortunately, it was a digital trip, but let's hope in the future we can meet face to face again. So
yeah, definitely.
All right.
So there was very, very few claps. So I'll just, since there's no real audience that can clap, so I'll just clap for you. Thank you so much for the presentation.
Thank you.
And thank you for being part of it. Yeah. Thank you for watching. Bye.
Bye.